Hello, friends. Welcome back to another session of EC Made Easy. After looking into fundamentals of bipolar junction transistor, the BJT, and field effect transistor, the FET, it is now time to see how they compare each other. What are their features? What are their benefits? What are their advantages? What are their disadvantages? And so on. So let's start with our BJT. BJT is made up of three layers: emitter, base, and collector. The emitter current IB controls the collector current IC. So IC is proportional to IB and IC is given by HFE times IB, and HFE is very greater than 1. So therefore IC will be very much larger than IB. A small IB will produce a large IC. Getting to FET, we have three terminals again. One is the source, other one is the gate, and third one is the drain. And the drain current is controlled by the voltage across gate and the source. So the voltage between gate and source is usually in the reverse bias will control the drain current. So the drain current is proportional to voltage between gate and source, and because this is reverse biased, so the higher reverse bias applied, the larger will be the depletion layer, and the larger depletion layer means smaller channel available for conduction. So this has something a negative relation with ID. The more is VGS, the less will be the ID. So this is ID is under control of VGS. What does that mean? It means that IC is the output current in this system, ID is the output current in this system, and this IC is derived out of IB. IB means flow of current, flow flow of electrons creates current, flow means kinetic energy. Whereas this voltage is a potential energy. So that means our BJT is a current driven system, whereas FET is a voltage driven system. What do you mean by these two, current driven and voltage driven? Current driven means if you want to maintain a constant output, in case of BJT, we need IC that requires IB. That means so we need to spend energy to flow this IB and creates the output current. Whereas if you want ID, then you need VGS. So VGS means apply potential, that too in the reverse bias. Therefore, no current will flow, only voltage is required. So no spend of energy. don't have to spend any energy to create this output current. So this can be easily explained using an example. So imagine about a tap. So there is a spring controlled tap here, which we commonly see on railway platforms, where if you want water to flow, we need to push this knob. So push the knob, water flows. So as long as you want water to flow, keep pushing this. So that is one way of controlling flow of water. There's other way of controlling flow of water is a tap. Here the orientation of the knob will decide will the water flow or not. In one orientation, water will flow. In another orientation, water will not flow. So, if the water is not flowing and you want water to flow, just turn the tap, it starts flowing. And as long as you keep the tap in that orientation, the water continues to flow. You don't have to do any extra work, just rotate it once and it continues to flow. Here, if you want water to flow for some time, so for all that time, you need to ensure that somebody is pushing this knob. Whereas here, you don't have to ensure for that time, just keep this tap in that orientation, that's sufficient. So spend energy just to rotate it once. So rotate once and get the water forever. Yeah, definitely make sure that water is available. Rotate once, get water forever. If you want water forever, so make sure to push this forever. So that's a difference between working of this tap, working of this tap. So this works on kinetic energy. You need to spend energy all the time, whereas this is on the potential energy. So the FET is equivalent to this. So just apply potential. Yes, it starts current to flow. But to make sure that this output current is there in BJT, you need to ensure that base current is flowing. For base current to flow, energy has to be spent. No need to spend any energy here. You need to spend continuous energy here. Therefore, this is a BJT system is a one which needs extra energy for its working, whereas FET system does not need that extra energy for working because this works on potential energy, this works on kinetic energy. So another example I can quote here is about a door which has got a spring connected to it so that it always remains in the closed position. For some event, you want to keep the door open to ensure that guests come in and out without any disturbance. You don't want guests to keep on opening door all the time. So you just want to keep the door open. So then you have one option is use a big fan here, and this big fan will produce a wind like effect and keeps the door open and will not allow door to close back. Keep the door open because of the wind energy created by this fan. You can make the door kept open. As long as fan is running, the door will be open. So the moment fan is switched off, door automatically gets closed. So as long as you want to keep door open, ensure that fan is running. Other option is pull the door and keep a big stone here. Pull the door, keep the big stone here, and the potential energy of this door is sufficient to oppose the door closing and hence will ensure that the door remains open. So you need to spend some energy to get the stone and place it here. And once the stone is placed here, till you disturb the stone, the door is not going to close. So a small energy is to be spent for keeping the door open if you work in stone version. But if you get into fan version, then make sure that fan is running forever as long as you want door to be open. So running fan means running electricity, using electricity, that means spending energy. Using stone means nothing to spend any energy. So this works on potential energy, this works on kinetic energy, and that's the difference between working with FET and BJT. So wherever possible, we prefer to work with FET. So FET is more preferred because of its energy efficiency. Done. So that's it for now. Till next session. Take care. See you. Bye.